Welcome to Voice Bootcamp, a global name in unified communication. Hello, my name is Faisal Khan, CEO and founder of Voice Bootcamp Incorporation. In this self-study kit of deploying Cisco Unified Contact Center Enterprise with CVP 11.5, I'm going to discuss about the architecture of Contact Center Enterprise. Now, we're going to focus on the package UCCE solution, hosted contact center solutions, and the enterprise edition. Those are the three different architecture we're going to focus on. Now, the package solution, which we talked about in the previous slide, is a pre-designed single pair of duplex system of UC server. So basically, you will get two physical server with on-box virtual machine that are described by the OVA template. Now, the package UCCE virtual machines provide the essential set of contact center functionality, which it can be used for call and non-voice task processing. Also able to provide prompt, rich VXML scripting, voice response collection, agent selection, queuing, and reporting functionality. Now, the package CCE is a robust solution with a high availability and solution for serviceability. It is deployed in a full duplex mode. Hosted environment, on the other hand, is almost all of the component and features of the enterprise solution, but it is designed to share by multiple customers. The contact center supports a subset of UCCE model and can be used to provide two different layer of services in addition to the full contact center. One would be the aggregation layer and one will be the management layer. Now, the aggregation layer can be used to provide an aggregation point of contact for all the calls from all the customers coming in to this SBC platform. It could also be served by maybe a third party or even Cisco SBC solutions. That shared aggregation will then be connected to the voice gateway, which in return then connect to your call center environment. Now, shared management component, where you do your day-to-day administration of through the virtual center, vCenter, through UCS manager of creating profiles, and many other components. Customers, for example, where they have agent located in their office, will then use a web interface to log in to your contact center using Cisco Finance Server and some sort of software-based phone. So in this scenario, you build a contact center with a multiple customer, instance 1, instance 2, instance 3, and each instance will represent different customers. Same contact center will be shared by those customers themselves. So when agent 1 calls comes in, it goes to customer 1 instance. When a call from agent from customer 2 comes in, it will go to customer 2 instance, for example. So this is the benefit for a service provider to provide a hosted based solution so that a small to mid-sized company can rent contact center on needed basis. So they don't have to buy the entire solution if they don't have the requirement for it. The enterprise solution architect, the enterprise edition, which is meaning that a contact center for a company, is a solution that delivers intelligent call routing, network to desktop connectivity using CTI, multi-channel contact management for contact center agent over the IP network. It is a software-based ACD that allows you to provide automatic call distribution and route the calls to the next available agent. It is interconnected with Call Manager, CVP, Call Manager for PBX, CVP for IP IVR, and queuing, and of course Cisco Voice Gateway for Ingress and Egress call. And of course Cisco IP phone will be used for the agent. Now, one of the very first parameter devices we talk about in this environment is your Ingress, Egress, and VXML gateway. The Ingress gateway, which will be used to receive call from the service provider. Now, we could of course use SIP trunk, or we could use T1 or E1 depending on your physical location. and then that call will go from the Ingress gateway to your CVP or to your call manager server. Whereas in some environment that you may need to send calls out to PSTN or to the rest of the world, in that case we'll use a gateway that happens to be an egress gateway. Both Ingress and egress gateway can be the same router. Now the VoXML browser happens to be known as VoXML gateway, which is responsible for rendering VXML application. Now this is required if you're going to use CVP only. So in this scenario, VXML browser will communicate with CVP server to process any sort of VXML application. Now keep in mind one thing is that you can actually achieve all these three functions from a single router, providing that you have the necessary resources. Cisco Unified Voice Portal, which is your IP IVR server. Now UCCE being one of the most advanced application or contact center application, however, there's two functionality that UCCE cannot do. It cannot queue the call and it cannot provide IP IVR. Can you imagine that a very expensive contact center software cannot do the two most important tasks of any call center? When an agent is not available, queue it, or ask customers questions and response on behalf of it, which is interactive voice response. Neither of these two functionality cannot be achieved by UCCE alone. Heck, UCCE cannot even, a script cannot even write to a database. So what it does, it relies on Cisco Unified Customer Voice Portal to provide those features. Now, CVP itself is a very advanced contact center application. It has a scripting capability that can read write to database, read write from a file, and many other functionalities like writing calls to an external Java applet, making your own custom DLL file, integrating with it, pretty much any full-fledged programming environment. Of course, it is related to IP IVR programming. So CVP is a choice of protocol when it comes to integrating with UCCE as a IP IVR solutions. Now the core component of UCCE, for example, happens to be call router, logger, PG, admin server, and live data server. The call router happens to be the brain of your your contact center, or often known as the ACD, is responsibility for making all the routing decision, or how to route a call to our customer contact. Now, whenever a call comes in from a customer, we can call that either a call or a customer contact. The router is part of your central controller. Logger, on the other hand, happens to be a server, Windows 2012 server with Microsoft SQL Server, is actually the database server, which is responsible for storing configuration data. Logger temporarily stores historical reporting data for 14 days. And Logger is also part of central controller. Now, what makes a central controller? A central controller is when it consists of a logger and a router. Again, a central controller consists of a router and a logger in a fully functional environment. If router is active, logger is down, basically we can say it may not be necessarily a central controller. Peripheral gateway, or PG, which is basically an interface between the UCCE server and peripheral devices. So this is my UCCE, and if I want to talk to a peripheral such as call manager, and let's say I have CVP. Well, these call manager, CVP, or maybe even Avaya gateway, or Avaya call manager, call control device, these are all known as peripheral. And in order for them to talk to UCCE directly, well, they cannot first of all talk to UCCE directly. So what do you need to do? Put an external device in between called PG, peripheral gateway. So from the peripheral perspective, it is the gateway to UCCE. So what happened in general is that because each peripheral can be different type, you have Avaya has its own protocol, CVP has its own protocol, call manager happens to be a different protocol. So there are different type of signaling method between peripheral and UCCE. So what Cisco have done, they put a peripheral gateway whose job is to translate those signals from the peripheral to a signal that UCCE can understand. Now, typically in here, where between the UCCE and PG, we use a protocol known as GED, whereas between call manager and PG, we may use JTP, for example. So that's one of the difference between, that's what the PG really does. Now, your contact center solution can use various type of PG. For example, you have an agent PG, you have VRU PG, you have MR PG, all co-resident in a single virtual machine. Now, a single virtual machine can only have one agent PG. Each PG includes one or more peripheral interface manager, or PIM. Now, think about PIM is like a virtual interface. So think about PIM is like a virtual interface. Like, you know how you have a fast Ethernet interface on your Cisco router, and then you connect that which is connected to the network, and then you can create virtual interface in order to have a multiple layer 3 addresses. Well, PIM is kind of similar to that. It's a virtual interface to our different peripheral. So I could have one PG server, and inside I could have a one PG with multiple virtual interface. These are PIM. And each PIM will point to a specific IP address or devices. Now, administration and data server, which happens to be the server that allows you to configure the UCCE system and obtain real-time reporting and historical reporting. Those are the three functionality of admin server: configuration, real-time reporting, and historical data storage. You can deploy at least one admin server is required. You don't have to have more than one, but it is recommended that you must have at least one admin server for every logger pair. Live data, on the other hand, is basically allows you to process event between the router and a PG. So any communication between the router and the PG will be captured in a live data, and then you can use UC Intelligent Center, which is a reporting tool, to view those in live as the call come in. So every call that is coming in, the router and between the PG and router is being copied to a live data server. Now the live data can be installed in the same server as your CYC reporting server or as a co-resident, or you can separate them into two different individual servers. Now, the combination of various UCCE components work in a particular virtual machine can sometimes be identified using different names. For example, if I have a virtual machine that has a router and a logger installed, we usually call that central controller. If the same virtual machine, another virtual machine has router, well, my apology. When we have a router and a logger installed in a separate virtual machine, we call it a central controller. But if we have a router and a logger in the same virtual machine, we call that logger, but it is still a central controller. But the server can be identified as a logger server. Whereas if the virtual machine contains a router and a PG, this becomes a call server. If this happens to be a logger, and an AW database, the administration server, we will call that a data server. But these names are just basically a name for you to maybe label it or identify it or reference by, whatever, but they really don't have any much significance. What is important is a role. Name is irrelevant. Now, next topic will be the communication between various components with PG and the various components. So in order to communicate with UCCE, so this is your UCCE solution right there. The red box is a UCCE, and in order to communicate with that, the peripheral, such as here, they need to communicate with a device called PG. Now PG usually hosts the PG configuration, and one other thing in PG is called the PIM, Peripheral Interface Manager, which is a logical connection between the call manager and the PG server. See this green segment? This is called the PIM, Peripheral Interface Manager. Each call manager cluster or CUCM cluster, there is at least one PIM acting as agent PG. Each redundant agent PG pair can support up to 2,000 agents. Redundant meaning that you have let's say you have a call manager here, publisher, another call manager here, subscriber. You have PGA, PGB. A points to publisher, B point to subscriber. In this scenario, this kind of environment can support up to 2,000 agents. Some deployment, however, require multiple PG if you need to go more than 2,000 agents. For example, if you need to support 4,000 agents, then you need to add multiple PIM and therefore multiple routing client in order to support the higher number of agents. You deploy each PIM on a different agent PG. Deploy only one PG for each virtual machine. So one given single virtual machine can only have one PG that is pointing to an agent PG. Sorry, one peripheral that is pointing to the agent PG. So I'll give you an example. So let's say I have a call manager cluster in USA. This is the US cluster. And then I have a separate cluster in India. Now both of them are call manager. Now the agents are sitting right here. So if I have a PG here, I can point this if I want to use the agent service for both of them, this particular PG can only point to one call manager at a time. I cannot point to this. The reason behind that is the way the TFTP server, the JTP plugin in the PG server can only point to one CTI manager. So it is important that you understand that in order to point to multiple call manager cluster, who is going to, if both of them happens to provide, let's say, agent service, that you have to have a separate PG for that physical virtual machine. For each CVP server or unified IPR, there is only one VRU PIM. Each VRU PIM can reside on either a VRU PG or a non-reference design such as generic PG server. CTI server, on the other hand, allows you to connect Cisco FINAS to the agent PG and central controller. So one of the role of CTI server is to provide call control, provide the ability for the agent to log in through the FINAS server. It handles the call control and agent request from the agent desktop. In this case, the desktop happens to be the FINAS server, web-based FINAS server. Each agent PG must include a CTI server if you want to be able to control the agent through the some sort of agent desktop software. A CTI service will connect to one side or other, depending on which side is active. The CTI server process agent state requests and update the central controller for considering a routing decision. So your FINAS server will point to CTI server will point to agent PG, Agent PG ultimately points to your call manager, UCCE, as well as CM, call manager. JTP, one of the most important communication signaling protocol between the call manager and PG server. So Cisco Unified PIM, which is a sign-in process, establish a JTP communication between the call manager and your agent PG. CTI manager communicates with the JTP to the UCCE server. Each subscriber in your cluster, or even including publisher, has their own CTI manager running. Unified Call Manager PIM, or the Peripheral Interface Manager on the agent PG, must communicate with only one, or can communicate with only one CTI manager. So this is why you need to point one to subscriber primary call manager. You need another PG server to point to secondary call manager. Each redundant pair of PG shares a unique CTI user ID. This is often known as the application user ID. For example, because the CTI manager can only talk to one PIM, this can cause some problem if you have a scenario like this. For example, you have a subscriber 1 which connects to the Cisco router voice gateway. Subscriber 2 in the same cluster talks to the UCCE through the CTI manager. So if a call arrives, what's going to happen? A call will arrive, oops, not a very attractive color, to the voice gateway in subscriber 1, which will send a signal intercluster message to subscriber 2 because that UCCE is registered to subscriber 2. So therefore the call has to go to subscriber 2 first. From there the call will be sent to the PG server. So what does the JTP communication process? It has three distinct type of messages: routing control, device and call monitoring, device and call control. And routing control, which is a message that enables the cluster to send a request, route request instruction for the UCCE, meaning when a call comes into call manager sends a request to UCCE saying, what do I do with this call? It also sends device and call monitoring, a message that enables the cluster to notify their contact center enterprise that there is a change of the agent phone or the call. Device and call control, message that enables the cluster to receive instruction from the contact center of how to route the call to the agent. So these three kind of work together. So in most call you will have all three messages executed. Now most calls may use all three types, but of course it's not necessarily true. When a call arrives, call manager will send a routing request to instruction from the UCCE. This particular step will match the first item. So this particular steps right here matches the routing control. Second, when subscriber receives a routing response from the UCCE that an agent is available, so UCCE will send a message back to it. So let's say I have my voice gateway here. This is my call manager, my PG, and then I have my UCCE. So imagine a call comes in inbound. So this will match this particular messages. JTP will use this type of message to the UCCE. Now, when UCCE send a request saying the agent is available, the extension of the agent is 2001 and 2001 sitting right here. It sends a call to the call manager, rather. This message will be carried over, I believe this one. Message call manager cluster receives from the UCCE. Let's say if the agent decide to log out or log back in or not ready or ready, that message will be, or sorry, when the phone is not working, or agent phone is unregistered, then that information will be carried over device and control monitoring. Like for example, when a subscriber receives, when subscriber notify the UCCE that the phone is ringing, that will be the device and call monitoring. So these are the different type of messages that JTP will communicate with UCCE server through the PG server. Then you have the administration server and real time. The main interface for UCCE configuration. Remember what administration and real time server does. It has three functions: configuration, real time report, call reporting, or historical call recording. It includes a database, which is a copy of the logger. It receives update from the central controller to keep the database synchronized. A client will then be able to read the data from the database and send update through the central controller. When we want to deploy an administration server, we can define what kind of role that admin server will play. And these are different type of roles. When I have AW role, AW-HDS role, AW-HDS-DDS role, HDS-DDS role. You do not deploy admin server in a redundant pair, though you can if you want to, but you don't have to. You can deploy at least one admin server for each logger. If one admin server fails, you can sign in to your client AW to another server if you need to. Now, AW acts as an authentication server for Cisco FINAS server. So when Cisco FINAS logs in, AW is used to authenticate the user. So let's take a look at the role AW, which provides two functionality: configuration and real-time. Handles all the configuration change and real-time reporting for Intelligence Center. Real-time data server portion of the AW will use AW database, which you must create in advance, to store the real-time data and configuration data. Real-time data reports the real-time report will combine these two types of data, which is real-time and configuration, to present a near current snapshot of the current system. Kind of give you the exact overview of the system. This role, however, do not support any historical reporting. Then you have something called configuration only AW. Now I know this shows configuration only, but that particular server does not really let you configure. For example, this is my UCCE. And then I have a server right here, the AW config only. I cannot log into this server and manage this UCCE system. However, I can use an external software called CCMP, which is known as Cisco Contact Manager, I believe Manager Portal, which is a remote management software that manages the UCCE through this particular server called AW configuration only server. It's kind of like a gateway bridge between them. Though config only server says is a configuration, but you cannot actually do any configuration on this server. It is only used for this external application. Historical data server and detailed data server, HDS, DDS. Data extraction and customer report for your call detail recording. So it contains more detailed recording of the call as well as summary of the call. You should have at least one server of this type on each side of the redundant logger pair. This role, however, does not provide the following: no real-time, no configuration. Historical data server and detailed data server provides long-term historical data storage. So it basically kind of a permanent storage. HDS, historical data server, basically provide historical summarization of data for 15 or 30-minute interval for the reporting purposes. DDS, on the other hand, which stores the detailed information about every call that comes in. Now, DDS is not a database. It is basically a table in HDS database. AWHDS. And AWHDS includes kind of a bit of both. It includes the administration, so configuration database, it includes real-time, and it includes historical reporting, except no detailed data recording is enabled. But it does everything else. So technically, your router will feed information to the AW database every 15-minute or 30-minute interval. The logger configurations are also managed from the admin database. So the router will push the real-time information to the admin server. The logger will push the configuration to the admin server as well. Now, it is possible for a small to mid-sized deployment. You have all role played in the same server, AW-HDS-DDS. Real-time data server will use the AW database to store the real-time data and configuration data. And it also provides HDS and DDS, but this is only good for small, like 2000 deployment model. If more than 2000, you need to separate them at some point. HDS stores historical data summarization of 15 or 30-minute interval. DDS stores detailed information over each call, but you can configure the system where you can purge the old data on a regular basis by scheduling a purging timeout. So you should always purge a database when it reaches 80% or 90% is maximum size. Live data, on the other hand, is a framework that processes a real-time event with high availability for live data report. So this is basically a server that either can be co-residence to reporting server, CUIC, or it could be a dedicated server serving its own purposes. Live data will continuously process agent and call events from the PG to the reporting server. So every event that occurs, live data simultaneously or continuously push that information in real time to the intelligent reporting client. PG and router will push agent and call event to the live data server as the event occurs. Live data will then continuously aggregate and process the event in a stream and publish the information on a web interface. The agent limit, as you can see, if you follow the 2000 model reference design versus 4000, 12,000 and contact director, number of active agent you can have in your environment is 2000 on the 2000 reference design, 4000, 12,000, 24,000 respectively. Active agent on each call manager cluster could be 2000, say pretty much the same numbers. Configured agent, however, is different. For 2000 design, you can configure up to 12,000 agent. For 4000 design, you can configure up to 24,000 as agent, but only 4,000 can be active at any given time. For 12,000, you can configure 7,200 agent. Sorry, 72,000 agent. Agent with trace on enable 100 for pretty much all. Agent desk settings 2,000, 4,000 respectively. Number of mobile agent per agent PG 1000 if you use a nailed up connection versus 500 call by call connection. Active enterprise chat and email 1500 for 2000 design, or pretty much 1500 for all. Number of agent per team 550 agent per team throughout the class throughout the design guide. Teams to which agent belongs to, pretty much one. Agent can belong to only one team at a time. Skills per agent. Skills per agent 15 skills per agent. For 2000, 4000, and 12,000, only 5. Number of agent skills in a group, 12,000 agent skills agent in a skill group, 24,000 in 4,000 design, and 72,000 in 12,000 design. Number of attributes for precision routing, 50 attributes pretty much throughout the design guide. So that's pretty much all there is for this architecture. We will be seeing you in the next chapter.